Okay, so chapter 13, question 16, the mixed exercise at the back. We have got a diagram showing the curve C with equation y. Where's my pen? Right then, question 16. So, y equals x, 8 minus x, okay, and the line with the equation y equals 12, and which meets at the points L and M. Okay, determine the coordinates of points L and M. They've drawn us a nice little graph that looks something like this. It's got a thing like this and a thing like that, and it says this is L, this is M. And they do also have this labeled up with a right angle and it coloured in. Okay, come here. So something like that. Okay, and they've got the two graphs labelled up as you would expect them to be. Okay, you've got y equals 12 and y equals x, 8 minus x. Okay, right then, start one, figure out what point L and M are. So, when L and M are equal to y equals x, 8 minus x, it's going to be when 12 is equal to x, and I'm going to multiply it out here, 8x minus x squared. And that means we can change that around and get x squared minus 8x plus 12 equals 0. Okay, so what do we have there as an answer? Probably 2 and 6, isn't it? So x minus 2x minus 6 equals 0. Okay, normally solve these ones on the calculator, but when they are that straightforward, we can do it because minus 2 and minus 6 make the minus 8. 2 times 6 gives us the plus 12 because they're minuses. So that means we've got an x of 2 and an x of 6, meaning we have point L as 2, 12, because remember it's y equals 12 is that line, and M is 6, 12. Okay, part B. Let's have a look. Given that N is the foot of the perpendicular from M on the x-axis, work out the shaded area bound by N, M, and the curve C. All right. Basically, looking at that, to find the green shaded area, now that we know this is x is equal to 6, okay, we are literally finding the area underneath this graph. So y is equal to 8x minus x squared. Remember we multiplied it out. Okay, and so the integral of this between, what we haven't got is the upper bound, but because y is equal to x and 8 minus x, then we've got an x equals 0, which we could see on the picture that it went through 0 and x equals 8. So this point here, where it's coming back down here, is 8, and this point here is the 6. Okay, so we are going to integrate between 8 and 6 of 8x minus x squared dx. So we get raise the power by 1 and divide by the new power. Okay, 8x squared over 2 minus raise the power by 1, 3 divided by 3. What's that? 8. That's meant to be a 6, not a 0. 6. Okay. 8 divided by 2 is 4, so we've got 4 times 8 squared minus 8 cubed divided by 3. Take away all of that. 4, 6 squared minus 6 cubed divided by 3. Okay, calculate for that one. So 8 squared 64 times 4 is 256. 256. Take away 8 to the power 3, which is 512, divided by 3 is still 512 over 3, minus 6 squared, 36 times 4, 144, minus 6 cubed, 216, divided by 3, 72. Okay, so 144 minus 72 is 72. Okay, so we end up with 256 minus 512 over 3 minus 72. 256 minus 72 minus 512 over 3, 40 over 3. Okay, 6 marks. Right then, next one. Okay then, on to question 17 then. So, question 17, something similar. Diagram gives us y equals x minus 1. Alright, meeting the curve which has an equation of y equals x minus 1 and x minus 5. Alright, at A and C the curve meets the axis at A and B. Write down the coordinates A, B and find the coordinates of C. So they've given us a nice picture which looks a little like this. It comes in here, it does something like that, and then this graph comes through here like that, and we've got a nice 0, ABC, B and C, and then they've just labelled up the two graphs. Okay, so y equals x minus 1 and y equals x minus 1, x minus 5. Okay, find A, B and C. Right then, well, starting straight away, we can say that A is not an x, but a 1, x of 1, y of 0. Okay, we can say that B is an x of 5 and a y of 0 because it's where it cuts it, being the quadratic roots there. Okay, and now we need to find C. So we can say that x minus 1 for this equation is equal to this equation, which I'm going to quickly multiply out. So x squared minus 1x minus 5x, that sounds like minus 6x minus plus 5, because minus and minus is a plus. So solve this quadratic. X squared minus 7x, what does that become? Plus 6. Okay, straightforward enough, I think, in terms of it being a x minus 1 and an x minus 6, meaning that the C coordinate will have an x equals 6 as its x value. Okay, so we've got the 6 up there. Quickly finding what it is, we can put it into the y equals x minus 1, so that equals 6 minus 1, which equals 5, giving us a C of 6 and 5. Alright, find the area of the shaded region bound by the line and the curve. Okay, so the shaded region on this whole thing is, yeah, I'll go with that. Ooh, is this whole bit. Okay, Now then, I'm going to find this region in 2 bits because that bit there, you see that? Nope. Give me a different color to that. You can't see that either, can you? That green's quite intense. That's better. So this bit here is just a triangle. Okay, so the triangle of that we can work out, and we can use half the base times the height, and then we can integrate from B to C for the graph. Now, admittedly, if we do B to C, it's going to come under there. Okay, I'll tell you what we'll do. We'll do this triangle for the line, okay, going all the way up to C, and then we will do a bit of taking away from it as well for that bit there. Okay, so we need the purple bit and we need to take it away from the whole line bit. So let's have a look at this. We are going to have the integral of x minus 1 between the points of A, which was 1, and the point C, which is 6, between 6 and 1. Okay, 6 and 1 dx, and then we are going to take away the integral of the x squared. What was the rest of it? Careful not to have that bit in it. Minus 6x plus 5 minus 6x plus 5 dx, and that's going to be working until from 6 to, what was the other one? It was 5. Okay, so doing these two integrals, all right, taking one away from the other. Okay, raise the power, x squared over 2 minus x. Okay, and that will need to go between 6 and 1. Take away, right, x cubed divided by 3 minus 6x squared divided by 2 plus 5x divided by 1. Okay, you notice none of these have plus c's because they're defined integrals. Okay, quickly putting these all in then. Okay, what do we have there? 36 divided by 2. So correct, make sure you don't make a mistake on this bit because, you know, 18, you're better than that. 18 minus 6 minus 1 squared a half minus 1. Okay, taking away, what's that? It's going to be a 6. So 6 cubed. 6 cubes 216 divided by 3 is 72. 72 minus, is that 6 squared times 6. 216 again divided by 2 this time, so 108. Okay, plus 30 minus 5 cubed 125 divided by 3 is 125 over 3 minus, what's that, 5 squared, 25 times 6, 150 divided by 2 is 75, and 5 times 5 plus 25. Not a lot of space there, 25. Make sure you don't lose that. Okay, 18 minus 6 is 6. Minus a half is what I'm left here. A half minus 1 is minus a half. But it becomes plus a half because of the minus on the outside. So I've got 6 plus a half. So I've got 6.5. 6.5. Then what do we have there? We've got 72 minus 108 plus 30. Okay, that's minus 6. So I've still got minus 6 in there. And this 125 over 3 minus 75 plus 25 is minus 25 over 3. And because it's a minus, it becomes a plus 25 over 3. Okay. So take 6 away from that, 7 over 3. So we end up with 6.5. What was my 7 over 3? I've lost my minus on there. Let me just double check that. 25 divided by 3, take away 6 is 7 over 3, so it is minus 7 over 3. And 5 minus that answer, 25 over 6. 25 over 6, 4 and a sixth. So you probably saw my confusion on my face. What did I do wrong? Just coming back here, 18 minus 6 is not 6, but 18 minus 6 is 12. This should be 12 and a half here. Okay, 12 and a half, 12 and a half, which means then hopefully 12 and a half is 61. 61 over 6, which is, of course, 10 and a sixth. 10 and a sixth. Always worth sometimes using the calculator to do some of the simple arithmetic, because it's always so easy to make mistakes on. Anyway, question 18. No one wants something too perfect, do they? Question 18 then. Diagram shows part of the curve with an equation. Y equal P plus, what's that, 10x minus x squared. Okay, P is a constant and part of the line L, and part of the line L with the equation Y equals, okay, Qx plus 25. Okay, where Q is a constant, the line L cuts the curve at the point A and B. The x coordinate of A and B are 4 and 8. Okay, drawing us a nice picture. Something like that. And so they've got, drawn this in, A, C, B. Okay. Okay, and they say this point down here is 4 and this point here is 8. All right. Respect to the line through A parallel to X intersects the curve again at C. Show that P is equal to P equals minus 7 and calculate Q. Okay. So now we're going to show P equals minus 7 and calculate Q. Well, with that being there, we know that we've got a value of 4 on there and a value of Q on there. So the value of Y is equal to minus 7. So as this drops down here, it's going to become minus 7. Y equals minus 7 plus 10x minus x squared. When x is 0, when x equals 0, we can show that y equals minus 7 plus 0. Okay, so it cuts down there, which looks like it intersects with that. That's all right. We can also show that the value of the line when y equals 4, not y equals 4, but x equals 4. Okay. x equals 4, y will equal to minus 7, what was it, plus 10x minus x squared. Okay, so y is equal to minus 7 plus 10 times 4 minus 4 squared. Okay, minus 7 plus 40 minus 16. We end up with y equals, what's that, 40, take away 16, minus 7, 17. So a is equal to 417. Okay. Okay, so now that we've got that, we can use it to find Q, which is basically saying that y, which is 17, well, y equals, what was it, qx plus 25. Okay, did I write the wrong equations on the graph? Did I write any equations on the graph? No. Okay, y equals qx plus 25. Okay, so we can use the fact that we know it intersects at y equals 17, so we can say 17 equals q, and that was when it was 4. Okay, plus 25. So 17 minus 25 is minus 8. Minus 8 equals 4q, and so q equals minus 2. All right. Now they want us to find c, and of course c is when we are parallel with the x-axis, so that means it's going to have a y value of 17 again, because that's the y value of a. So when y equals 17, we need to look at the option of 17 equaling the quadratic, which was minus 7 plus 10x minus x squared. And as we bring that across, we're going to have, if I'm going to bring it this way, I'm going to have x squared minus 10x, and that's 17 plus 7, which is 24, equals 0. And we know that one of those values is 4, so the other one should be 6. So we've got x minus 4 and x minus 6, showing that the x value of c is 6. So c is 617. Okay. With that in, show that the shaded region in the diagram is bounded by the curve and the line segment AC using integration. Show you're working to the calculation. Okay. So, last bit, we want to integrate. This minus 7 plus 10x minus x squared between the bounds of 6 and 4. Okay. 6 and 4. So that we can then take away the integral between 6 and 4 of 17 dx, i.e. the line AC. Okay. So, okay then, so the integration of that is going to be minus 7x plus 10x squared over 2, that's going to be 5x squared minus x cubed over 3, 6, 4 minus 17x 6, 4. Okay, last little bit on this then to finish it off, putting in the numbers. So, minus 7 times 6 plus 5 times 6 squared, minus 6 cubed over 3, take away the minus 7 to the 4 plus 5, 4 squared, minus 4 cubed 3, take away 17 times 6 minus 17 times 4. All right. Final bits on that. Okay, so minus 42, 36 times 5 is 180. 6 cubed, I think we've done already. 216 divided by the 3 is 72, so minus 72. Take away 4 sevens, 28, minus 28. 16 times 5, 80, plus 80, minus 4 cubed divided by 3 is 64 over 3. Minus 17 times 6, 102, take away 17 times 4, gives us an answer of 34. Okay, making sure we don't have any silly numerical mistakes in this. 180 minus 42 minus 72 is 66. Okay, 80 minus 28 minus 64 over 3 is 92 over 3 minus 92 over 3 minus 34. So 66 minus that answer minus 34. 4 over 3, 1/3. Finish up there and carry on. Okay.